Postgraduate Brawijaya University, located in the city of Malang, East Java. We are ready to guide with the various study programs. Environmental and Development Research Management Program, Doctor Program in Environmental Science, and National Defense Institute. The Lemon Studies Master Program. Interesting facilities. And the best quality. Postgraduate Brawijaya University, reaching Postgraduate Brawijaya University, located in the city of Malang, East Java. We are ready to go into various study programs. Environmental and Development Research Management Program, Doctor Program in Environmental Science, and National Defense Insight. The Women Studies Master Program. Interesting facilities. And the best quality. Postgraduate Brawijaya University, reaching the future.
Universitas Brawijaya adalah kampus tujuan paling favorit di Indonesia. Para mahasiswa datang dari berbagai daerah di Indonesia serta dari luar negeri. Universitas Brawijaya semula merupakan yayasan perguruan tinggi bernama Yayasan Perguruan Tinggi Malang pada tahun 1958. Terletak di pusat kota Malang yang terkenal dengan hawa yang segar dan udara yang sejuk, Universitas Brawijaya telah menciptakan lingkungan kampus yang asri, dengan tata ruang yang terpelihara dengan baik dan didukung oleh tenaga pengajar yang berkualitas, baik dari dalam maupun luar negeri, menjadikan Universitas Brawijaya sebagai kampus yang nyaman dan kondusif untuk proses belajar dan mengajar, serta untuk mengembangkan bakat dan minat. Universitas Brawijaya membuka akses belajar yang seluas-luasnya bagi calon mahasiswa berbakat, termasuk mahasiswa disabilitas. Saat ini, ribuan lebih mahasiswa mendapatkan beasiswa dari berbagai instansi, baik pemerintah maupun swasta. Universitas Brawijaya memiliki 14 fakultas, Pascasarjana, dan program vokasi. Dengan didukung lebih dari 140 guru besar dan 400 dosen peneliti yang berpengalaman mengajar dan meneliti di berbagai bidang ilmu pengetahuan, teknologi, sosial, budaya, dan humaniora, Universitas Brawijaya siap mengembangkan proses pendidikan yang bermutu dan berstandar internasional untuk menghasilkan lulusan berdaya saing global. Untuk menunjang kompetensi dan keterampilan mahasiswa, Universitas Brawijaya menyediakan berbagai laboratorium dengan peralatan yang berteknologi canggih dan modern, termasuk laboratorium lapangan, sehingga budaya penelitian yang kuat terus berkembang ditandai dengan penemuan inovatif yang bermanfaat bagi masyarakat luas. Karya ilmiah yang bermutu dan inovasi diciptakan Sivitas Akademika sebagai wahana pendidikan, penelitian, dan pengabdian kepada masyarakat. Sebagai perwujudan komitmen sebagai world-class entrepreneurial university, berbagai sarana dan prasarana serta beragam wahana bagi berbagai aktivitas mahasiswa disediakan untuk menjamin terciptanya peserta didik yang unggul dan berprestasi. Banyak lulusan Universitas Brawijaya yang saat ini menempati posisi penting dan berkontribusi nyata di Indonesia maupun di tingkat internasional.
Dari pengajarnya dulu zaman saya kuliah banyak praktisinya, jadi saya ngerasa benar-benar kepake banget, bukan cuma belajar teori tapi prakteknya kita dapat.
Dari pengalaman kuliah yang paling berkesan ya karena saya anak organisasi, jadi ya di kepanitiaan, terus saya di sana belajar tentang kepemimpinan.
Dulu yang depan saya itu Fakultas Peternakan, sekarang udah berapa lantai udah ya, malah ada liftnya, dulu nggak ada.
Dengan semangat kami, Universitas Brawijaya akan menunjukkan kepada dunia pendidikan yang berintegritas dan humanis, serta berada pada barisan terdepan dalam pengembangan ilmu pengetahuan dan teknologi. Dengan bangga hati dan penuh percaya diri, lulusan Universitas Brawijaya siap menyongsong masa depan, building up global future. Universitas Brawijaya adalah kampus tujuan paling favorit di Indonesia. Para mahasiswa datang dari berbagai daerah di Indonesia serta dari luar negeri. Universitas Brawijaya semula merupakan yayasan perguruan tinggi bernama Yayasan Perguruan Tinggi Malang pada tahun 1958. Terletak di pusat kota Malang yang terkenal dengan hawa yang segar dan udara yang sejuk, Universitas Brawijaya telah menciptakan lingkungan kampus yang asri, dengan tata ruang yang terpelihara dengan baik dan didukung oleh tenaga pengajar yang berkualitas, baik dari dalam maupun luar negeri, menjadikan Universitas Brawijaya sebagai kampus yang nyaman dan kondusif untuk proses belajar dan mengajar, serta untuk mengembangkan bakat dan minat. Universitas Brawijaya membuka akses belajar yang seluas-luasnya bagi calon mahasiswa berbakat, termasuk mahasiswa disabilitas. Saat ini, ribuan lebih mahasiswa mendapatkan beasiswa dari berbagai instansi, baik pemerintah maupun swasta. Universitas Brawijaya memiliki 14 fakultas, Pascasarjana, dan program vokasi. Dengan didukung lebih dari 140 guru besar dan 400 dosen peneliti yang berpengalaman mengajar dan meneliti di berbagai bidang ilmu pengetahuan, teknologi, sosial, budaya, dan humaniora, Universitas Brawijaya siap mengembangkan proses pendidikan yang bermutu dan berstandar internasional untuk menghasilkan lulusan berdaya saing global. Untuk menunjang kompetensi dan keterampilan mahasiswa, Universitas Brawijaya menyediakan berbagai laboratorium dengan peralatan yang berteknologi canggih dan modern, termasuk laboratorium lapangan, sehingga budaya penelitian yang kuat terus berkembang ditandai dengan penemuan inovatif yang bermanfaat bagi masyarakat luas. Karya ilmiah yang bermutu dan inovasi diciptakan Sivitas Akademika sebagai wahana pendidikan, penelitian, dan pengabdian kepada masyarakat. Sebagai perwujudan komitmen sebagai World Class Entrepreneurial University, berbagai sarana dan prasarana serta beragam wahana bagi berbagai aktivitas mahasiswa disediakan untuk menjamin terciptanya peserta didik yang unggul dan berprestasi. Banyak lulusan Universitas Brawijaya yang saat ini menempati posisi penting dan berkontribusi nyata di Indonesia maupun di tingkat internasional.
Dari pengajarnya dulu zaman saya kuliah banyak praktisinya, jadi saya ngerasa benar-benar kepake banget, bukan cuma belajar teori tapi prakteknya kita dapat.
Dari pengalaman kuliah yang paling berkesan ya karena saya anak organisasi, jadi ya di kepanitiaan, terus saya di sana belajar tentang kepemimpinan.
Dulu yang depan saya itu Fakultas Peternakan, sekarang udah berapa lantai udah ya? Malah ada liftnya. Dulu nggak ada.
Dengan semangat kami, Universitas Brawijaya akan menunjukkan kepada dunia pendidikan yang berintegritas dan humanis serta berada pada barisan terdepan dalam pengembangan ilmu pengetahuan dan teknologi. Dengan bangga hati dan penuh percaya diri, lulusan Universitas Brawijaya siap menyongsong masa depan, building up global future.
Postgraduate Brawijaya University, located in the city of Malang, East Java. We are ready to guide with the various study programs. Environmental and Development Research Management Program, Doctoral Program in Environmental Science, and National Defense Insight. The Women's Studies Master Program. Interesting facilities. say, Bridging the Future.
Izin kami mulai nggih, Bu Hartati? Izin kami mulai nggih, Prof?
Okay, yes, I'm fine now. Okay.
Iya Mbak, masih mute, sorry ya.
Have a problem with
Okay.
it. Okay.
Honorable guests, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, my name is Nia and I will be your master of ceremony for today's guest lecture. I would like to welcome the Honorable Director of Postgraduate Universitas Brawijaya, Professor Dr. Marjono MPhil, Vice Director in Academic and Students Affairs, Bapak Fadila Putra, SOS MSI, Master of Public Affairs PhD, Vice Director in General and Finance, Bapak Andi Kurniawan, SPI, Master of Engineering, Dr. Science, Head of Master Program Environmental Resource Management and Development, Dr. Insinyur Hartati Kartikaningsih, MSI, Head of Environmental Science Doctoral Program, Profesor Dr. Insinyur Gatot Ciptadi, Head of Study Program in Postgraduate Universitas Brawijaya, Head and Coordinator Institution in Postgraduate Universitas Brawijaya. I also welcome the lecturers and students in Master and Doctoral Program in Postgraduate Universitas Brawijaya. I also would like to welcome our keynote lecturer, Honorable Professor Insinyur Dr. HASFALINA from Department of Biological and Agricultural Engineering, Faculty of Engineering, University Putra Malaysia. Good morning, Professor.
Morning. Thank you.
Honorable guests, ladies and gentlemen, thank you very much for joining our in1 guest lecture today. Today's topic for the lecture is about water pollution assessment. Ladies and gentlemen, for the first remark, I will come to Head of Master Program Environmental Resource Management and Development, Dr. Insinyur Hartati Kartikaningsi, MSc. Time is yours.
Thank you, Mbak Nia. Assalamualaikum, all of the
Waalaikumsalam.
audience. Good morning. Yeah,
Morning.
this 3-in-1 program is held every year since 2019. Correct, Professor? Yeah, at Brawijaya University.
Yeah, that's right. Yeah.
Yeah, it's to establish cooperation and research and dissemination of knowledge like this. I personally have taken advantage of this program with Professor Nurul Huda from Faculty of Food Science Nutrition University Malaysia of Sabah. Yeah, in collaboration in writing journal, and then this journal has been published in the Solfak Putra Fasnisco Food Science Journal in this month.
Okay.
Yeah. I hope in the future the collaboration with Professor HASFALINA can be still continue, such as joint writing article, joint research, and also writing book chapters together. Professor HASFALINA have research interest in bioenvironment engineering, wastewater treatment, and agricultural waste management. Topic lecture from our guest lecture provide enrichment to our subject environment policy and its implementation. This topic lecture was held in 6 weeks, yeah, 6 weeks, 6 until 8, yeah, and held in every Friday at 9 and until 10:30 a.m. Until from
baik, silahkan
Oktober ya.
Aktifkan ya. Kemudian di rename untuk memastikan.
Pak Gadrot, mohon maaf Pak Gadrot. That's fine.
Yeah. Yes, thank you. It held on 1 October until 22 October. I also thanks to all of staff in postgraduate program Brawijaya University for carrying out of this activity. In the last of the most important, let us to express of our gratitude to our God, our Subhanahu wa Taala, because we can attend to this program without any difficulties. Thank you. I return to the time and place to the committee of this program, Mbak Nia. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Hartati. For the next remarks, I welcome the Director of Postgraduate Universitas Brawijaya, Professor Dr. Marjono MPhil. Time is yours.
Thank you, Mbak Dia. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. Alhamdulillah, all praise in the Creator of the universe, Allah Subhanahu wa Taala. We are always healthy, so we have this wonderful program with Professor Haslina, Sorry. Yeah, on behalf of the Director of Pascasarjana, a postgraduate program, University of Brawijaya, we are thankful for this event. Hopefully, we can have the maximum to support our science and also our nation by doing this event. So thank you for the Vice Director at PATSAS and postgraduate program, also all of the head of study program and this postgraduate program at our university. May Allah give us the power and by saying Bismillahirrahmanirrahim, so this 3-in-1 lecture, this is officially open. Thank you very much, Mbak Nia. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Professor Marjono, for the remarks. Ladies and gentlemen, before we start the class, I would like to take a moment for the documentation. Therefore, please make sure you are on cam. The committee, please help for the screen capture in 2 sessions. To all participants, please make your Zoom on cam. Okay, for the first session, on 3 sessions. For the first, 1, 2, 3. Okay, for the next, 1, 2, 3. For the last one, 1, 2, 3. Okay, thank you. Ladies and gentlemen, now we continue to the lecture presentation from our keynote lecturer, Professor Insinyur Dr. HASFALINA Ceman. For this session, I welcome the moderator, Abdul Aziz Amin SPT MSc, to kindly start the session.
Thank you very much for the mastering of ceremony, Ms. Nia Noviana. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. My name is Abdul Aziz Amin. I am the person of charge to be a moderator in this morning, in this 3-in-1 lecture. Information that 3-in-1 lecture program is held annually by all faculty, especially also in the postgraduate study Universitas Brawijaya. Which this program will have 3 lectures that consist in the original lecture, and then visiting lecture, and then the practice unit lecture. So in this today, we will start the first meeting of 3-in-1 program with the help by the Magister Program of Environmental and Development and the Doctoral Program of Environmental Study, Postgraduate Study of Universitas Brawijaya. Okay, the first of all, it's honorable for the Director of Postgraduate Study, Universitas Brawijaya, the Vice Director 1 and Vice Director 2, Postgraduate Study, Universitas Brawijaya, and also Head of the Magister Study Program of Environmental and Development, and then Head of Doctoral Program of the Environmental Study, and also it's honorable our visiting Professor, Prof. HASFALINA binti Ceman. Assalamualaikum, Professor.
Waalaikumsalam.
Nice to meet you. You can join in this program. Okay, in the all audience, the Prof. HASFALINA will have around 30 or to 45 minutes to give the lecture to us, and then we have the question answer in the last is around 20 minutes. So the audience, if those who have the question, they can raise the hand in the icon of Zoom in the room, or write the chatting in the chatting room the question to Prof. HASFALINA. Okay, maybe it's a limited time. We can start our lecture. Before it, I will try to briefly introduce our visiting professor. She is Prof. HASFALINA, Insinyur Dr. HASFALINA Ceman. She comes from Department of the Biological Agriculture Engineering, Faculty of Engineering, University Putra Malaysia. Now she has graduate PhDs in the Civil Engineering and Geoscience in the 2006 in the University of Newcastle upon Tyne, UK. And then the appointment on this position now is the Deputy Director of the International Office, University Putra Malaysia, and also the commit member of Supervisory and a Seminar Postgraduate UPM, GKP PTP University. And then also she have previous the appointment, the position in University Putra Malaysia. Okay, today's topic, we will talk about the water pollution assessment. Prof. HASFALINA will have around 30 or to 45 minutes to give the lecture. Maybe it's a limited time, as Prof. HASFALINA is already. Okay, again, time is your Prof. HASFALINA. Thank you very much.
Thank you so very much, our Mr. Moderator today, Mr. Abdul Aziz, and also I actually would like to praise Allah Subhanahu wa Ta'ala for being able to be with all of you today, even in the virtual class. Yeah, so there is no problem now, as we can have virtual class cross the border without need to be in physical presence. Yeah, in the class. So I would like to thank first of all the organizer for this guest lecture, yeah, 3-in-1 program. And this is my second invitation. Yeah, last year I've been invited by Dr. Sri Suhardini actually. So we get to know each other, even get to know virtually as well. And then I get contact from Mr. Abdul Aziz, and we have also get to know each other virtually as well. And now I've been invited for the second time for this year. So Alhamdulillah, thank you very much for this invitation. And also I would like to thank Honorable Director, Professor Dr. Marjono, the Postgraduate Director, and also Dr. Hartati as well as the Chief, Chief Executive for organizing this very good program. Yeah. And also Dr. Ibu Nia Noviana for the brief introductions, and also Mr. Abdul Aziz for the introduction about my background as well. So thank you very much again for this invitation, and inshallah I would like to praise Allah Subhanahu wa Ta'ala again for choosing me to be here today. It's Friday and hari Jumaat, insyaAllah penuh keberkatan kita kata ya. Allah give us all of this opportunity to be together today, insyaAllah. So I've been given a very short time actually. So allow me to share my screen. Okay, let me. Open that one first. I hope we have.
It's okay, Professor. Okay.
Let's see my slide now. Hope you're able to see the slide.
Yes, clearly appear.
Okay. Okay, so I would like to welcome all of you to University Putra Malaysia. So maybe some of you not yet been to UPM, maybe some of you already been to UPM. So it's fair for me, let me just explain a little bit about University Putra Malaysia. So this is actually my faculty. So Faculty of Engineering facing this beautiful lake. Yeah. So if you would like to come and visit us next year, inshallah, so I can show you around. Yeah. So we also have Faculty of Medicine, And we also proud to inform you all that we also have our own hospital, teaching hospital, HP UPM, which actually this is the building. And we also actually have medical faculty as one of the faculties. Yeah. So with this hospital, we actually able to actually conduct the lecture hands-on at our Hospital Pengajar. Normally we call it HP UPM, Hospital Pengajar, University Putra Malaysia, or teaching hospital. So on the left side, this is actually the old facility and structure of the University Putra Malaysia. We actually were previously known as the Faculty of University of Agriculture or University Pertanian in Indonesia, similar to Bogor University. Yeah, so I've been to Bogor, I've been to University Andalas, and I've been to University Gajah Mada, but not yet Brawijaya University. Maybe in the future, I can be at Brawijaya University, inshallah. So
Yes,
you
please.
are also welcome to visit University Putra Malaysia. Yeah, so for your information, the immigration has opened the border for the mobility program, for the students to enter UPM for physical classes. So inshallah there will be what we call positive movement in terms of the what we call movement for these physical activities. Yeah. So at different state, we have phase 1, phase 2, and phase 3 until 4. So that means if you actually have lower cases per day, then you will be moved to another phase. So right now in Selangor, UPM is actually located in Selangor. So we are now moving to second phase, which is actually, that means we are allowed to do many activities, such as meeting, physical classes. Before this, if you are having high cases, you are in a movement, what we call restriction order. So we actually need to be at home most of the time. So Alhamdulillah, I think it's a very good and positive. We are going to actually live with this what we call COVID, and it's now in the phase of where we actually will adapt ourselves to this new norm. So yeah, without further ado, as being informed earlier, I'm also the Deputy Director of Putra International Center, or iPutra, and I'm also the Professor at the Department of Biological and Agricultural Engineering, Faculty of Engineering. And I would like to thank again Kementerian Pendidikan Kebudayaan, Riset and Technology, Universitas Brawijaya, Pascasarjana, for this guest lecture 3-in-1. Today, I'm going to actually begin my lecture on the title Water Pollution Assessment. So basically, I will start with the definition of the pollutants and also definition of the water pollutions. Then we go into the sources of pollution, and we like to know so what are the basic types of the pollutions, physical, the biological, and also the chemical pollutions. And then later we have to actually understand about the definition of water quality. We need to know about the water quality, because when we talk about the water pollution, is related to the water quality. And water governance, I actually pick up example in Malaysia. So in terms of the assessment, we have water quality index, water quality standards, and also water quality modeling. But it's not going to be details in terms of the water quality modeling, because I also been informed that this class also for undergraduate, not only for postgraduate. So I try to make sure that it's not too advanced. Actually, I also actually teach the class for master program, water quality control. And most of the slides here is actually from my 6 hours class actually, which I tried to compile in just 45 minutes. So I tried to make sure that you get some of the main juice of the title, which is actually water pollution assessment. Okay, so the final conclusion, I leave it to the organizer. Maybe we can also have additional class later on if you were interested to know about water quality modeling. Yeah. So basically, what is the pollutants? Because this is the main definition, which is very important. The title itself is about water, yeah, water pollution assessment. So we need to understand first what is the pollutants. In Malaysia, we have one policy, which is Environmental Quality Act 1974, or we use as the short form EQA. Yeah. So the definition of the pollutants according to EQA in Malaysia is any matter prescribed to be scheduled waste. Scheduled waste here is actually hazardous waste. Yeah, we call it as the scheduled waste because it has to be specific disposal. Yeah, for the scheduled waste, or any matter whether in a solid, semi-solid, or liquid form, or in the form of gas or vapor, which is emitted, discharged, or deposited in the environment in such volume, composition, manner, and as a, oh, let me check this one here, as the adverse pollution actually, right? So the water pollution itself, that means these pollutants actually presence in the water. So the water pollution is actually any biological, chemical, physical change, yeah, in water quality that has a harmful effect on living organisms or makes water unsuitable for desired uses. So we can imagine that we need water, yeah, is our important sources, okay. Then we need actually to make sure that it's safe for us, yeah, which is actually not harmful, yeah, and also it's for desired uses. We use water for drinking, we use water for agriculture, for aquaculture industry, for irrigation, yeah, you can name it. Many of the activities need water. So water quality for desired uses, yeah. So that means we have specific water quality for certain purpose. For example, if you would like to use water for drinking, you must boil the water first. If you are going to use this kind of water, right? You need to filter, make it look pleasant for you to drink this kind of water, okay? And this pollution actually is keep increasing years by years. If you can see, this is actually the projections from 1950 until 2050. Yeah. So with the world population keep increasing, as also the water pollution, because water pollution is actually caused by human activities. We are actually the one who created all these pollutants. Yeah. So different human sources add to the pollution of water. And then actually these water pollutions can be divided into point and also non-point sources. So these are the two basic source where this pollution come from. One is the point sources, which is actually you can see the specific entry point, such as the pipeline here. And normally we able to treat and also control the water pollution before it's discharged into the surface water. However, for the non-point sources, it is actually diffuse sources. You're not able to see any specific entry. And so that is difficult to trace, manage, and also regulate. So these are the few examples. Yeah? As I mentioned, point sources from specific locations. So you can see the drain, drain pipes, ditches, or the outfalls. It can be from the factories, from the power plants, for sewage treatment plants, underground coal mines, or even oil wells. And it could be from domestic sewage, or it could be from industrial waste. Yeah. So normally, one of the terms that we usually use is municipal sewage, which is actually the domestic sewage plus the industrial waste. Yeah. And point sources also could be from industry and wastewater treatment, mostly located near the waterways. And 80% of the point sources is actually the main contributor for the water pollution. If you can see here, this is the main source, which is actually the point sources here. So you can see that this is sort of plumes, yeah, from the pollutants. So it's actually emerging into this surface water. So similarly in this situation as well, you can see the contaminant plumes, yeah. And also one of the example point sources is the landfill. Yeah, earlier in the 1970s, the landfill normally without any liners or no clay liners. Yeah, so the seepage of the leachate, which is the dissolved pollutants, can pass through into the soil here and then into the groundwater. So now, recently, we also have actually new technology, especially when we are dealing with the scheduled waste or hazardous waste. So it's very important to make sure that all the landfills, yeah, with the plastic liners, with the clay barriers, these are all to make sure that we prevent all the leachate, yeah, to the seepage into the groundwater. And non-point sources, okay, as I mentioned earlier, without any specific location. So it will discharge into particular body of water. Normally when you see the runoff, it will go to the lowest level, yeah, lowest level, and normally in the river or in the pond nearby. So you can see that this runoff could be from the farm fields or the feedlots, yeah, golf courses, or the garden. So this is an example of the urban runoff. Yeah. So urban runoff normally from the streets, yeah, from the parking lots, and it's actually transport the pollutants, including oil, herbicides, or nitrogen, phosphorus. This is example from agriculture runoff. Yeah. And all of these actually containing the nutrients, which also enrich the blue-green alga phytoplankton, which is what we call as the eutrophication problem later on. So basically, water pollution can be divided into biological, into physical, and also chemical. Yeah. So the biological is involved the bacteria, viruses, or the organic waste, and physical such as heat, yeah, sediment, radioactive materials, and the chemical including heavy metals, nutrients, and also pesticides. So let me explain each of these types. Biological pollution is actually the most serious one, yeah, when we talk about the human health, because it has pathogenic or disease-causing organisms. So most importantly, waterborne disease such as typhoid, cholera, yeah, bacteria, enteritis, polio, infectious hepatitis, yeah, this is actually through the waterborne disease, yeah, and that means these organisms, yeah, the pathogenic, able to be transported by media water. So if we use the same water, then we actually easily get this disease. Yeah. So if any coliform bacteria are present in a water sample, infectious pathogens are usually assumed to be present also. So you can imagine that if you have runoff from the feedlots, so entering the river, so it could be coliform bacteria present in the water, yeah, in the river. These are the examples of the disease, yeah, related to the pathogens. And these are the infectious organisms. Yeah, it can be through the bacteria. The disease related is typhoid, cholera, the virus, which is hepatitis, polio, or the protozoa, parasites, yeah, such as amoebic dysentery. Yeah. If you can see, this is actually how it looks like under the very what we call high resolution microscope. This actually example of the organism secreting enterotoxins as well. And water is actually the main media, yeah, for this disease. to be transported. Yeah. And bacteria, the most famous one is E. coli, yeah, Clostridium vibrio-cholera, and also this is one of the viral rotavirus. Yeah, I encountered this infection virus. Yeah, rotavirus. It is actually a very contagious virus that causes watery diarrhea. Yeah, my son actually at his age, yeah, 5 years old, got infected, yeah, with the rotavirus. Has to be hospitalized for a week, yeah, to treat this viral infection. So rotavirus normally contagious, and then it's easily spread out. Yeah? So it happened when he was at the nursery, and one of his friend actually got infected. So all the students actually got infected, yeah, by this rotavirus. So it's actually similar to what happened to the COVID-19 now. Yeah, it's contagious. So but this one is actually treated. Yeah? So after hospitalized, he's actually fully recovered, and now we have a vaccine, yeah, for the rotavirus. So basically, the biological pollution involved with the microbiome metabolisms, yeah, which actually able to alter the surface water quality. So if we can imagine, this is the oxygen demanding materials or organic material which actually being disposed into the surface water. And what happens is that the microbe in this water will use the organic material, because the organic containing carbon, hydrogen, oxygen, yeah, nitrogen, which is actually the main source of the food for the microbial activity. So when the microorganisms actually doing their activity here, so they will actually use the dissolved oxygen or DO here. Yeah, dissolved oxygen, which is not much in the water, will actually depleting, yeah, because of the activity here. So this is why it's very important to make sure there is no what we call pollutants, yeah, to be entered into our surface water. And is relate to this oxidation process, what we call as the degradation process, yeah, will happen and actually consume the dissolved oxygen in the water. That's what we call as the oxygen demanding material. And normally we measure, yeah, by using biological oxygen demand and also chemical oxygen demand, yeah, to actually relate with the oxygen demanding of this process actually. So the sources of this oxygen demanding or organic material, it could be domestic sewage, yeah, as it's containing most of the organic matters come from us, yeah, human waste, food residue, paper industry, yeah, containing a lot of lignin, cellulose, animal waste and droppings, yeah, crop residues, meat packing plants, and also medical facilities, yeah, containing all of these waste, yeah. Then second one is the physical pollution, yeah. So these physical pollutants can be in form of heat, yeah, also can be in form of solids, suspended solids or sediments, or it could be radioactive materials, yeah. So this is the heat where normally if involve electrical power plants, yeah, coal power plants normally, because it's involved cooling and heating, yeah. So many fishes, especially salmon and also trout, yeah, they're really sensitive to the temperature difference. Normally they live only in cold water. So if there is a changes of the temperature, it will affect this species, yeah. So warm water also hold less of oxygen, yeah. So that means we have less dissolved oxygen in the water, and also it's create thermal shock as well. So thermal pollution usually containing effluent, yeah, from the cooling system, such as the power plant or other industries, alter the water temperature difference actually. So it can be raising the temperature or lowering the water temperature, yeah, from the normal levels. and this affect the water quality and aquatic life. Yeah, so water temperatures are usually much more stable, so that the aquatic organisms, yeah, tend to be poorly adapted to rapid temperature changes. Yeah, even a change at 1 degree can be lethal, yeah, to aquatic life. And I mentioned earlier as well, the differences of the temperature also actually influence the dissolving of the oxygen as well. Yeah, if it's warmer, then less oxygen will dissolve in the water. So less oxygen available for the aquatic life. Yeah. And then also this sediment, yeah, this can be from the water or wastewater. It can be organic or inorganic particles. It can be from the soil erosion, deforestation, yeah, agriculture activities, building and also road construction activities. These are the main sources where these sediments can come from. So the implication is that it will chokes and fills the lakes and reservoir with the sediments. Yeah? And salmon eggs, for example, suffocate. Yeah, salmon population reduce. Actually, not just salmon, other fish also will have the negative impacts on this. Yeah, because you can imagine fish need to breathe. Yeah, by using the gills, their gills. So if the gills actually being what we call chokes with the sediments, then they're not able to breathe. Yeah, so this is actually contribute to the changes of the diversity in the particular area. Turbidity and also reduce the euphotic zone, and also is actually have the reduce the photosynthesis as well actually. Yeah, the sediments, particles harbor pathogens and also pollutants. Yeah, these sediments is not just particles. Sometimes it's also bring along the other. It can bring pathogens. It also can bring heavy metals as well. Yeah, or other pollutants. And sediment and heat degrade the water, and silt and sediment are considered, yeah, the largest source of water pollution in the United States. Yeah, basically it fill up the lakes and also reservoir, and it also can clog hydroelectric turbines as well. Yeah, and makes purification of drinking water more costly because you need to treat the water containing more sediments. Yeah, and not only that, it's also block the sunlight because the murky and also cloudy water. So you also not be able to do the activity, recreational activities such as swimming, yeah, fishing. Yeah. So this actually has a very big actually impact on the environment. If you can see, this is some of the example. Yeah. Then the chemical pollution, number 3, involve the nutrients. It can be also inorganic pollutants, heavy or toxic metals, salt, acid, etc., petroleum, oil, synthetic organic chemical, organic pesticides, industry solvents, yeah, DDT, and also etc. When we talk about nutrients, it involves 2 main nutrients here, which is nitrogen and also phosphorus. And this is actually main nutrients for growth. Yeah. Then mainly this phosphorus base, this nitrogen and phosphorus mainly come from the phosphorus-based detergents, from the fertilizers, food processing waste, animal and human excrement, agriculture runoff, which is about 50%, and also sewage. So the impact of nutrients is that it will create this eutrophication, yeah, because natural eutrophication happens actually slowly, yeah, in the stagnant water such as lake, yeah, but then when there is extra what we call extra nutrients here, it will actually increase the growth of the algae. Yeah, so when there are too much of the algae, it actually lower the level of dissolved oxygen in water. So many species, yeah, such as aquatic animals, fish, yeah, no longer able to survive. And addition to it, excess level of nitrates also will reduce the bloodstream oxygen carrying capacity. and leading to a number of undesirable health effects for humans. And normally for nitrogen, we measure it in the water as a form of nitrate or the ammonium. Yeah. So the phosphorus, this is actually the form of the phosphorus that we measure in water. So nutrient addition actually stimulates the primary productivity, which is actually producing the organic compounds from this activity of the photosynthesis. Yeah, so it will actually producing new biomass here and also oxygen. Yeah, organic compounds formed by primary producers provide energy to consumers, which is the heterotrophic organism. So it's become food actually to the other organisms. But if with the less dissolved oxygen, then the other organisms may not also able to survive. Yeah, and the primary productivity, this is the algae. If you can see that this is what we call algae bloom. If it's actually covering the surface of the lake, then it's actually undesirable. Yeah, growth that we don't want it to be too much. Yeah. So it's actually increased the growth of the algae and also phytoplankton. So normally the excess nutrients actually overstimulate the primary productivity. This can be from the detergents, it could be from the natural runoff itself, manure runoff from the feedlots, or the urban runoff, and also could be from the discharge of the treated municipal sewage, yeah, primary and secondary treatments containing nitrates and also phosphates. Yeah, so and also could be from the internal combustion engines and also furnace, yeah, nitrogen oxides, and also from the runoff erosions from cultivation, mining, construction, and also poor land use. Yeah, so these all contribute to the land ecosystem nutrient overloads and breakdown of the chemical cycling. So later on, the excess of this nutrient actually will decrease light penetration, decrease the oxygen content in the water or DO, and also change the species diversity. Yeah, because some of the fish not able to stay here any longer, they need to move to the different place. So it's actually changed the diversity of this area. So this is what it looks like. Yeah, if you have full coverage of the algae on the surface, then the sunlight also not able to penetrate, yeah, at the bottom of this lake. Yeah, so the activity of the photosynthesis also will be interrupted. Yeah. So this plant nutrients is related with this eutrophication, yeah, because what we mentioned, as I just showed just now, is about the water clarity or transparency, yeah, is affected by chemicals, by sediments, or the abundance of the plankton organisms, and the clarity is useful measure of water quality and water pollution. So rivers and lakes, yeah, with the clear water and low biological productivities are said to be oligotrophic, which is little trophic, little less nutrition, and with extra well-nourished water, normally we call it as the eutrophic, yeah, which is rich in organisms and also organic materials, and human activities, yeah, is actually the main contributors, which actually accelerate the eutrophication. So this is actually explanation about the eutrophication here. It's actually natural process. It's happened naturally in the environment actually. But because of the human activity, we actually accelerate eutrophication, and we call it as the cultural eutrophication. So too much of the what we call produces algae bloom will actually make the process of what we call over time, yeah, ponds and lakes, yeah, often fill in, becoming marshes or even terrestrial biomes. Yeah, the rate of eutrophication depends on water chemistry and depth, volume of the inflow, mineral contents of the surrounding watershed as well, and biota of the lake. Normally you can imagine, yeah, this is actually the aging of a water body. So Maybe in the 5 years, you can see the lake there, but another 5 years, there is no longer lake, yeah, at the same place, because it's all become the aging, what we call as a aging, yeah. But if we actually put more, which is actually because of the cultural eutrophication, maybe within 2 years, yeah, you can speed up the process of aging, yeah, to happen faster, yeah, rather than it takes maybe 10 years. Now it can be in 2 years, yeah, you have no longer lake at the same place there. And the chemical pollutants also involve inorganic pollutants, example metals, salts, and also acids. And some toxic inorganic chemicals are naturally released into water, yeah, because of the weathering process itself. Human actually accelerate the transfer rates in these cycles thousands of times, yeah, above natural background levels by mining, processing, using, and discarding minerals. So we actually speed up the process, yeah, contributing to more of these toxic inorganic chemicals in the surface water. Yeah, among the chemicals of greatest concerns are heavy metals such as mercury, lead, tin, and also cadmium, super toxic elements, selenium, and also arsenics also have reached hazardous levels in some waters, and also other organic materials such as acid, salts, nitrates, and also chlorines. Yeah? Sometimes it's actually non-toxic at low concentration, but it will be concentrated enough, yeah, to lower water quality and adversely affect, yeah, the biological communities. So this example of the heavy or toxic metals and also metalloids. Arsenic, for example, can be from the erosion of natural deposits, could be from the pesticide waste, runoff of glass, the electronics production waste, it could be from the treated lumber, and even in the groundwater. Yeah? And this also, mercury can be from the erosion of natural deposits, but it also can be from discharge from refineries, factories, runoff from landfills, or even from the coal burning. Yeah, and the leads, yeah, this is actually from the electronics items, could be also from the plumbing systems, yeah, and paints, yeah, electronics items, fuels. So all of these actually contribute to the health effects. The most challenging, for example, is arsenic in groundwater. Yeah, you can see the effect on the health. It can create this skin cancer, yeah, skin lesions, internal cancer as well. And most affected countries, yeah, such as India, Taiwan, Bangladesh, Japan, even UK, and also Hungary, Mexico, Chile, and also Argentina, because most of these mainly use groundwater, yeah. So they're actually at the risk of arsenic poisoning, yeah, about 33 until 77 million in Bangladesh alone, yeah, out of 125 million people at risk because of arsenic poisoning, yeah, from the groundwater. And mercury can be present in the surface water, and is actually affect the vision impairments, yeah, involuntary movements, yeah, and this could be from the and normally mercury is actually what we call it will not be destroyed, but it can be transformed, yeah, from crab, from the shellfish, it can be consumed as the metal mercury, and then when the other organisms eat or consume, then it will be transferred, yeah, and we actually the final users, yeah, consume the shellfish or consume the fish, then we actually also going to be affected as well, yeah. So this actually some example of the toxic agents transmitted by water. Yeah, you can see here metals, the organic chemicals, including pesticide, chloroform, benzene, carbon, yeah, PCBs, and other toxic constituents such as cyanide, nitrate, fluoride, and even radioactive substances. And in most of the countries, we also have this petroleum, yeah, as a main problem as well. It could be from the ship maintenance, yeah. It could be from the oil changes, and the spills, the big spills account for about 5% of petroleum entering waterways. This is actually has been reported with actually kills 300,000 birds and even 2,000 otters killed because of this petroleum in water. And then potentially toxic persistent in the environment such as TCE and also PCE. These are the two toxic chlorinated hydrocarbons and other synthetic organic chemicals from the cleaning, pesticides, flame retardants, PCBs, and then also from the pesticides and also industrial or industry solvents, two principal sources because of the improper disposal of industrial and also household waste and also pesticide runoff. This is actually some of the issue why we need to have a good agriculture practice. If it's involved farm, and also there is also urban runoff from the roadsides, which is difficult for us to control. Thousands of different natural and synthetic organic chemicals are used in chemical industry to make pesticides, plastics, pharmaceuticals, pigments, and other products that we use in everyday life. So many of these chemicals are highly toxic. So exposure even to very low concentration, such as dioxins, can cause birth defects, genetic disorders, and even cancer. So this example of the pollution type, pollution category versus the pollution sources. It could be from point source, it could be from the non-point sources. So basically there is new, here is actually emergent, chemicals. This is endocrine disrupting chemicals. I'm not explaining this, but this is actually the emergent chemicals, mainly come from the bisphenol A, from the plastics, microplastics, which actually have tendency to disrupt our hormone, endocrine disrupting chemicals, and it could be from the point source and also from even from agriculture, So why do we need to assess water pollutions? As I mentioned earlier at the beginning, because water is a source of living. We need water for all aspects of our activity. And we actually, the human being, actually the main contributor of the water pollution. Any of this activity, untreated sewage, feedlots, animal waste, cropland, fertilizer runoff, sewage treatments, these are all human activities contribute to the nutrients, contribute to the pollutants, and these actually have the adverse effect on the environment. So basically, it's related with the water quality. Any of the pollutants entering the water have this adverse effect on the water quality. So water quality actually referring to the characteristics of water, good or bad, okay? So relate to its acceptability for certain purpose or uses. Usually when we want water for drinking, surely we want a good water, right? With the certain characteristics. You don't want to drink water with a smell, with a murky or very brownish color unless it's a TO, right? So you need to know what is the standard for a good water quality. Then the term of water quality is actually used to describe condition of water, including the physical, the chemical, the microbiological, and also even radiological characteristics, usually with respect to its suitability for a particular purpose. For example, for drinking, for recreational, for aquaculture, for irrigation, or even for industrial. So we have to put certain standards to get a good water quality for our purpose. So our water need to be both aesthetically pleasing and also safe to drink. And this is the term palatable, which is actually pleasant to drink and does not impart taste, odor, okay, and potable, which is water free of chemicals, free of organisms, and free from other contaminants, safe to drink. This is the potable. So So normally if you use it for drinking, yeah, we call it potable water. But usually for our purpose, we need our water to be both palatable and also potable. Yeah, so all the parameters that I described just now, consequently in the development of a water supply system, we want to have good water supply. Good water supply meaning that we need to examine carefully all the factors that might adversely affect the intended use of a water supply source, because we want to use this water as a for our daily life, so we need to put the parameters, okay, and standards. So what are the water users? It's 11 hours. Okay, so the water users is for the water, public water supply, water contact recreations, fish propagations, industrial, water supply is for agriculture, or it could be for self-fish harvesting. So typical parameter quality actually differ for each purpose or each use of this water. So normally if you are going to use water for the public water supply, it's important for you to make sure that the water quality, you measure the turbidity, you monitor the total dissolved solids, inorganic and also organic compounds, and also the microbes. So for the agriculture water supply, normally sodium, yeah, and also total dissolved solid. And for shellfish, dissolved oxygen, and also the bacteria or the biological parts, yeah.
So, I'm sorry, HASFALINA. Is
yes.
3 minutes left? Is okay. I'm sorry.
Yeah. I tried to speed up. Sorry. Okay. I hear that because it's already 11 now. So water resources in Malaysia is actually under federal constitutions, and also we have different states, yeah, to look into the water sources in Malaysia. So basically, major water pollutions come from the BOD and also ammonium nitrogen and also suspended solids, yeah, from sewage, from the land clearing activities, yeah. And in Malaysia, we have water governance involved. For example, if water for drinking is under Ministry of Health, is water for food is under Ministry of Agriculture and Food. And if water as utility is under Ministry of Energy and Natural Resources, and for water as a resource is under Ministry of Environment and Water. And under Ministry of Environment and Water, there is one department which is Department of Environment, and this department is very important because it's responsible to prevent, eliminate, control pollution, and improve the environment, yeah, inconsistent with the EQA just now. And there is also other government agencies such as DID and also Department of Forestry. These actually involve for the different tasks, yeah, to actually for the riverbank protection and also flood warning system. And under DOE also there is environmental impact assessment, whereby if you have any new project, yeah, you need to actually come up with this environmental impact assessment. You need to identify, predict, evaluate, and communicate information about the impacts on the environment of a proposed project, yeah, before you get the project approval and implementation. It is a must, yeah, if you would like to come up with a new project such as agriculture, airport, drainage, irrigation, yeah, fisheries, or forestry. Yeah, you need to come up with EIA. And under DOE also, they have water quality monitoring by using water quality index, which is actually to establish, this is actually to detect water quality changes and identify pollution sources. But the water quality index only monitor weightage only 6 parameters: DO, BOD, COD, ammonium nitrogen, suspended solid, and pH. Yeah? So this is the formula for the calculation, and this is also the sub-index. Yeah, this is how it's actually calculated based on the what you call ranges. Yeah, if it's less than 8, you use this. If it's than me, then you use this equation. So it's up to this equation with the weightage, and one of the output actually you will get water quality index, and you can classify the river basin according to their index. Yeah, if it's clean, it's between 80 and 100. It's polluted between 60 to 80, and very polluted if less than 60. Then this is actually under interim national water quality standards for Malaysia, and you can classify the water quality index according to the classes, which is class 2, class 1, 2, 3, 4, and also 5. Yeah, that means class 1 is a very good, yeah, quality of water. No need to have any additional treatment. Yeah, so class 2A is actually with the conventional treatment required, and it could be also good for fisheries too. Yeah, sensitive aquatic species. Number 3 is for water supply, but you need to have extensive treatment required. And class 4 suitable for irrigation. And 5 is none of the above. So from the W quality index just now, we able to classify and actually identify river basin in Malaysia from 2008 until 2007 in the category clean, slightly polluted, or polluted. Yeah. So the numbers actually increased in 2017. I don't have the current actually data, and the last one is in 2017. Yeah. So in Malaysia, we have water quality monitoring station at most of almost at all states. Yeah, located at the upstream and then also at the downstream as well. And in Malaysia, we have water quality standards specific for drinking water, industrial, yeah, groundwater for agriculture, groundwater for drinking, even aquaculture. Yeah. So this is just to show you example national water quality standards in Malaysia with the class and different concentration. Here, this is the limits. Yeah, for arsenic, for aluminium, for all these parameters. Yeah. And this is the standard groundwater for drinking water. And this is for groundwater for agriculture, right? So this is for palm oil mill effluent. Yeah, this is actually also from Department of Environment on the Industrial Effluent Regulation 2009. So some of these involve drinking water for standard A. That means if the location of the water is for intake point for drinking, then it's much stringent. Yeah, if you can see the BOD here should be 20, and this is for standard B. Yeah, 50 milligram per liter. And these are for the aquaculture, for the animal husbandry. Yeah. And the POME, palm oil mill effluent, this is from industry. If you can see here, okay, BOD if less than 20 milligram per liter actually is comply with the standards. Yeah, but then if you can see the color is still brownish color, but there is no problem there. They still can discharge the water into the surface area, the surface water. Yeah. So now we can imagine that if we dispose this discharge onto the river, yeah, so you can see which river will be impacted. Is related to the dilution. Yeah. So if we have concentration, but then with the high dilution factor, then actually we can reduce the impact of the pollutants in the water, because the loading is actually concentration times flow rate. Yeah. So, but then if you have thousands of pollution sources in the same river basin, then this is what we have the problem now in Malaysia and also any other countries. One of the way to monitor or predict, yeah, so of the water pollutions in the river basin is by using water quality modeling. One of the famous one is actually Stratford's equation. This one is actually to study water pollution as a water quality modeling tool. Yeah, so it's actually model the dissolved oxygen in river or stream. Yeah, with the distance by degradation of BOD. Okay, this is how it look like actually. So you can put in the mathematical and you can predict, yeah, for how long, yeah, from this source of pollutants entering this area, then how long it will take to back to the normal in terms of the dissolved oxygen, yeah, and the distance, yeah. So normally the water quality model use score to E to K, Mike, InfoWorks, visual plumes, and normally it river models, estuary models, coastal models, or even multi-purpose models. So you can simulate water quality process and also kinetics by using water quality models. So I'm not going to teach about this one. So that's why I just show you what actually we able to model the water quality actually. So water quality models can be used to determine the impact of an effluent discharge towards a body before the discharge happens. So you able to predict, and this is also very important to help authorities determine the suitable discharge quality and also quantity without incurring damage towards the environment. So I put the name of the person here. This is actually engineer Dr. Zakir Zainuddin. He's the expert in the water quality model. So maybe in the future, if you like to have class, you can invite him personally, yeah? So I conclude here, if we don't care about our past, we cannot hope for the future. So it's up to us. We want to choose this picture or we want to choose this picture, yeah? So without our self-awareness, all the best policies and even best plans, yeah, to ensure water conservation is protected will not be successfully implemented. Okay, thank you so very much. I think I end my presentation today. Yeah, thank you. Terima
Yes,
kasih.
thank you very much for the nice presentation, Prof. HASFALINA. So in the next agenda, actually we have the question answer, and then I already read the question for in the chatting room, and there's some question. So maybe in the question answer or discussion now, I'll try to read our 3 questions, and then maybe we will split it by 3, and then maybe later Professor Valena can answer. Okay, for the first question in the in the chatting room is from Miss Prisa listening room. She asked whether there is a case brought to the court in Malaysia related to the water pollution. If any, could you please briefly explain what the case about and what decision of the case? Nor if there is no case, perhaps you can explain why. Actually, she has asked about the brought the court in Malaysia. It's the first question. And then for the second question, about how far our technology can remedy the problem of the water pollution as the in this presentation, because know that with recent technology it can solve the problem, but fact is not. So what is the real problem, Professor Valina? And then in the third question is the chemical pollution from farming often is not released by society, but it could be harmful in the long term. It's not cause a big effect, malnutrition. And then my question from this Ms. Prisa, is there any mechanism in Malaysia, especially to control the level of water pollution from several activities such as agriculture activities? Maybe this the first in the one session, a 3 question. Time is yours, Professor Velna, to answer.
Okay, thank you, Mr. Aziz. And also I have 4 questions here. So I start with the first one. I'm still sharing my screen here. So I can stop sharing. Okay. So case related to water pollution in Malaysia, yeah, there are many actually. The current one, normally we also have problem with the ammonia discharge into the river by factory nearby, yeah. So sometimes normally in a year we have 2 cases like this, and we have to switch off and close the our treatment plants, yeah. Because need to clean up because some of this ammonia entering our facility for drinking, for utility, yeah, for actually supply water to our domestic purpose. So it's actually because of the overflow sometimes, yeah. They have some very not what we call not good in terms of the design. So during certain time they have overflow, some of the pollutants entering the river. So this is also actually has been taken action by the Department of Environment. So normally they will need to investigate where the source come from, which company, yeah, before they can take action on that, on the company. And some of the company actually they said they are not intentionally to do that activity actually, but it's because some of this they have the explanation for this, yeah. And the biggest one actually the issue that we have because of the what we call illegal dumping, yeah. So illegal dumping of the chemicals, of the unused pollutants in the soil. And then the effect now we can see in Sungai Kim Kim, that is actually the biggest environmental news that we actually encounter 2 years back. If I'm not mistaken, we actually have toxic vapor, yeah, entering our environment, our atmospheric there, and most of the area, the students, yeah, they actually fainted, even vomit, yeah, they're feeling very bad, yeah, because the atmosphere filled with this volatile and toxic gas, yeah. But that is actually happened nowadays, but the illegal dumping has been done by, we don't know who actually responsible, yeah, because you can see the effect now, but it happened long time ago. So this is actually one of the issue that even now we're not able to figure out who's actually responsible for this. This is why the issue happened, right? And they actually keep doing this maybe for a long time ago, and the 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 impact we'll see now. So this is actually the issue, yeah. And most of them actually we able to treat the river, yeah. But we really hope that we are not going to encounter any other issues similar to this one, yeah. Because this area is actually located to industrial area, so could be illegal dumping happened long time ago. So there is no one responsible for this, okay. And case related to any other case, yes, as I mentioned 1 and 2 just now, actually there is also other many other cases related to illegal dumping normally, yeah, because some of the industry during that time they will go to this river, yeah, to the pond and just dump all their pollutants, yeah, in the surface water without we knowing about it. So only when it's getting severe, then the public will report to the Department of Environment, yeah, because the smelling is too bad, yeah. You can see the bubbling on the surface of water, so you know that there is something happened there, yeah. So this is actually the problem that normally we encountered, yeah, in Malaysia. I think it's also happened in many other places, yeah. The person that actually do it because they don't want to spend money, yeah, to do the treatment, yeah. So normally they cut short and just dump, yeah, illegally. So this is what happened, yeah, related to all of this water pollution. Because as I mentioned earlier, if there is a project you want to actually open company related to any of the related to impact on the environment, you need to actually get license from Department of Environment. You need to come out with the proposed what you call technology to treat the waste that you are going to get from this project. Yeah, so you know how much of the waste that you are going to produce and what are the technology that we are going to use to treat this waste. So you actually need to report to the Department of environment earlier before. So the DOE will monitor and provide the license. And normally DOE also inspect, yeah, randomly all of the factories, yeah, all of this company to make sure they actually comply with the regulations. Yeah, for example, they will take the water from their outlet and bring to the lab, or even they measure in situ, and they will get what we call penalty, yeah, if they don't actually comply with the standards as I just showed just now. Yeah. Okay, so I hope I answered the questions, right? Secondly, how can technology, yeah, for example, able to remedy all of these problems, water pollution issues. Actually, we have come out with many of the technologies, yeah, for treatment of the waste. But then, as I mentioned, self-awareness is very important. Illegal dumping is happened because we don't have that self-awareness to protect the environment. So it can happen even we have all the best technology with the rules and regulations, yeah, with the act, but still there is still the problem there happen because of this illegal dumping by the the person that actually not have the self-awareness. Yeah. So this is also very important for us. That is actually, I think, the real problem of all of this issue. Yeah. So in terms of the technology, we have actually come up with many of the technology available, yeah, for drinking water, yeah, because if you would like to use the water for drinking, we have all this technology. It's just that if we actually we actually get too much pollutants in the water, in the source of water, then we need to treat with many of the chemicals. We need to add more alum, for example, yeah. So we need to add more chemicals and more money. That means the treatment will be much costly. So the water source actually, as I mentioned, we have class 1, yeah. That means no treatment, no need any treatment because the water itself is very clean. So you can just use it directly, yeah. So that's why we want to get the class 1 for our water actually, so that you don't have to spend much money, okay, for the treatment of water. So if we at the stage of class 5, you can imagine that very bad, poor water, and you need to spend more money, and it's very costly, yeah, for us to do the treatment. Yeah, so you need to add more chlorine, more alum, yeah, all of the chemicals you need to add more, yeah, to treat this kind of water. So that's why it's very important for us to protect at the main source before it get pollutions in, yeah, into the surface water as our main source of water. That is also the water that we use for drinking. Yeah. I think that's for number 2. And number 3, I'm not that clear with the questions. Sorry, can
Okay,
I?
Professor, I will read the question. In the chemical pollution from farming, often is not released by society, as in the Indonesia maybe, but it could be harmful in the long term. So the question is how long is harmful the effect of manufacturing in this pollution?
Okay, right. So actually, because so for example, okay, I received recently a sample from groundwater, yeah, from one of a company, and the company would like to use this groundwater for drinking water. So they actually requested us to actually check in terms of the standard, yeah, whether they comply as a drinking water or not. So basically, after measurement, we can see that exceed limit in terms of the arsenic, yeah, selenium, some of these metals as well in the water. So the same questions, yeah, can I consume this water, right? So this actually has the impact or effect in the long term. Yeah, you cannot see it now because it's related to the cancer, it's related to the internal problem, internal health problem. Yeah, but it based on the concentration as well. How much of the concentration in the water? It can be 0.02 milligram per liter, and if you consume the daily, then the negative impact will be seen maybe in another 5 years. Yeah, so because it's low concentration, but if you taking it regularly, daily, so the concentration will be increase in our body, yeah, by day. Yeah, so that's why you are not going to see it immediately. Yeah, so this is very important. Why actually when we can see examples in the Bangladesh, yeah, many of them actually having arsenic poisoning, yeah, because they use groundwater as the drinking water. So they not even know about the concentration and they keep consuming this water for a long time. Yeah, so they can see the effect when they start having the disease, yeah, on their skin, yeah, so they can see that how is that very bad, yeah, in terms of the health. Yeah, so that is actually one of the reason. But the concentration, this company, for example, they actually mentioned that they conducted the similar analysis 5 years back. But during that time, there was no arsenic detected in the water. But after 5 years, they detected and they mentioned that around the surrounding area is now have been the plantation area. So high usage of the pesticide and also fertilizer. So this could be contribution to this arsenic and also other aldrin also been detected in this groundwater now. Yeah, so this could be because of this activity surrounding. Yeah, so the water quality analysis, especially for drinking water, is very important, mainly for the purpose of our safety. Yeah, so normally for Malaysia, for example, we actually monitor the quality. We have actually another authorities, yeah, which is called as the SPAN, yeah, which is involved for the monitoring water quality for any of these water utility. Yeah, if you are going to use groundwater for drinking, yeah, you need to actually check in terms of the standards of the water quality for drinking. So that's why I show with you all example of the standards, because if for that different purpose, you have a different standard. Yeah, for drinking is much stringent because that is actually involve our safety. Yeah.
Okay.
Okay, I think.
Yes,
Am I
Professor.
answered that questions? Right. And one more, right? Questions?
Yeah. Maybe actually we have a lot of the question, Professor Lina, but in Indonesia, our audience also is located in the middle of time of Indonesia, which now is the start for prepare of Jumat prayer. Maybe in this session, I will ask one question from the audience, maybe one question only. This about the POM in Malaysia. POM is treated through an aerobic digestion that converted into electricity. Then what you, Professor Fasmina, to update the current situation of energy generation from POM in Malaysia, because in Indonesia, research from Traction Energy Asia show that only 10% of the mill applies in the AD installation for POM. Maybe it's one question only, Professor.
That's very good. It's industrial question. Yeah, because that is actually the 10 years back, actually, we actually involved, like UPM also, we have collaboration with the QTech in Japan. So we have actually developed one of the collaboration with one of the palm oil mill. So we have this biogas being set up, yeah, at one of the palm oil mill to produce biogas from pome. Basically, this technology is there, yeah, because and currently in Malaysia, nearly 80% of the palm oil mill with the biogas system, yeah, mainly in Sarawak and Sabah, yeah, they actually use actually produce biogas, yeah, from pome, and even Even we also actually have this technology, but it is actually a very important, I think, in terms of because at the early beginning, the government actually provides some initiative, yeah, because if you actually provide the electricity to the TMB, yeah, Malaysia, we use TMB, you get a special industrial tariff, and you also get in terms of the carbon reduction, you are able to get some initiative from the government, yeah, but it's actually no more initiative like that, yeah. So during that time, many of the palm oil mill actually take into consideration, and they actually implement this biogas system at their mill, yeah. But now it's actually their own initiative, yeah, because they still have the profit, yeah, from this biogas system, because they're able to use the electricity for their own consumption. Even one of the palm oil mill in Sungai Tengi under Felda, Sam Darby, yeah, they actually use biogas as the compressed gas, yeah, for the industrial purpose. So they can use this biogas such as methane, yeah, as a compressed gas, like in the cylinder that we use at cooking at home, yeah, for industrial purpose at this stage, yeah. So it will be good trend, yeah. Maybe later on in the future we can use methane gas for cooking, to replace the LPG that we are using now, yeah. So, but this one is actually from the pomade, yeah. So maybe in the future they can come up with the what we call effective system, and then because right now one of the problem, I think disadvantage is the cost, yeah. It's very costly. This system is very costly, yeah. So that's why the return of investment normally can take about 30 years, yeah. But that means to get the profit, you need to invest a lot of money before you can get the profit, yeah. So the ROI could be 20 to 30 years, yeah. So this is actually the drawbacks of the system right now, yeah. There is a lot of investment that the company need to put earlier before they can actually harvest the profit, yeah, in the end. So, but this is a very great technology, and I can see that maybe in the future they can have what you call compacted methane gas, yeah, for the domestic purpose. So maybe we can replace, yeah. But right now, because we still have LPGs, we still have petroleum, we still have coal, so we are not desperately, yeah, looking for this, you know, this method, yeah. So that's why we're still actually looking for the alternative, but then not really at the implementation stage yet, yeah. So still we have many alternatives right now, yeah, whether to choose what system and what technology. Okay, I think there is one question about the agriculture activity just now, but I cannot recall. It's about the agriculture activities, yeah, is also contribute to the water pollutions. The question is number 4, Mr. Aziz. I cannot recall. Is that I'm not yet answered the last questions, I think?
Yes, the last question that you delivered before, that the mechanism, especially in Malaysia, how to control level of pollution, especially in the agriculture activity.
Yes, agriculture is actually very what we call non-point sources, yeah, tendency of producing pollutants from diffuse pollutants, yeah. So we actually very difficult to control, mainly in terms of the application of the fertilizer, yeah, pesticide. This is actually where we have the problem with the non-point sources. We're not able to treat and we're not able to control. So the non-point source is still major problem, yeah, from the agriculture runoff, yeah, because with the good agriculture practice, as I mentioned, we can actually reduce in terms of the pollutants, yeah, entering the surface water. For example, right now, instead of they put fertilizer on the surface of soil. Now they dig and make a hole, yeah, so that the fertilizer on the surface will not be swept away, yeah, during the heavy rainfall. So this actually can reduce the what we call surface runoff, yeah, during the from the agriculture activities, especially in the plantation area, yeah. So other than that, I think the other activities, agriculture involved for the feedstock, yeah, normally for the animal husbandry, we actually moving forward for the what we call implementation, yeah, of the modern technology for the manual treatment, yeah. So for example, for poultry, we actually already have um, um, technology converting manure into the compost, yeah, by using vermicompost. There is also few of the company use biogas, yeah, to convert their actually manure into biogas as well, okay, for internal usage. Yeah, so this is also a positive way. And for your information, for the agriculture activities, for animal husbandry, it is under Department of Veterinary in Malaysia. So another ministry actually involved to monitor the pollutants released from this activity, yeah, into the surface water. So we have Department of Environment, yeah, but if it's involved with the animal husbandry, then it's actually under another authority involved, yeah. Okay. So that's number 4. Okay, number 5 done.
Okay.
I'm not able to check. Yeah.
Okay, Prof. HASFALINA. Actually, still there are some questions from to the Professor HASFALINA, but is indicate that this presentation is very interesting. But I'm sorry that because its time is limited, I was contacted by committee, but I'm sorry for the audience. We cannot answer all the question from the audience to Professor Lina. Maybe because it's not the last time. The next week we will have still the second meeting. Maybe the audience still can they give the same question to Professor Lina. Okay, Professor Lina. I'm really sorry.
We are going to have another class, right? Yeah. So for next week, and then can keep the questions for the next class, or can share with me. I can answer maybe in the next class.
Yes,
because this is the first class, so I don't know what is the expectation as well. So that's why I over excited, yeah, and extra time here. So sorry about that as well.
Okay.
So, I would like to thank you to all the participants, and hope we can see again next week.
Okay.
Inshallah.
Inshallah, Professor Lina. Okay, the audience, I'm sorry, Lily, that the time is limited because in the Indonesian time, we have to prepare for the Jum'ah prayer. Okay, before we closing that, I will the information, but the 3-in-1 program in this today is the first meeting, but we have still the 4th meeting with the Professor Lina with the help in the 7th October with the topic about material for environmental sustainability. So the audience that the question cannot answer today can give the question to Professor Lina next week. Okay, Professor Lina, before I closing, maybe I will lead the conclude of this meeting about the water pollution assessment. Basically, the water pollution assessment is short is from physical and the biological and the chemical. And then the water pollution, usually is come from the human activity also. And then we have known that 2 basic avenue of water pollution is have the point source and then non-point source. And the non-point source is from the agriculture runoff and urban runoff, and the point source is specific on the entry point, the treated control before discharging. Okay, the chemical pollutant, that nutrient, with the head wall table and the pollut table. Also, in Malaysia we have the department that handle of the water pollution, that academic, the DOA, and then as Prof. HASFALINA also saw, that environmental impact assessment is the document, is different type of the water pollution, also the different method for measuring pollution. Okay, in the last PowerPoint of Prof. HASFALINA also mentioned, if we don't care about our past, we cannot have the future. That's all for me as the moderator. Is conclude for this meeting. Okay, as a moderator, representative of postgraduate study University of Brawijaya, I really thank you very much to Prof. HASFALINA. Taken the join in the class. It's very interesting class because we have a lot of questions that cannot answer today, but we can continue the next week for the next meeting, next lecture. Okay. Maybe at the committee, I also represent to close this meeting. Maybe as the moderator, I said wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Pak Aziz. Thank you Prof. Lina.
Terima kasih, Prof.
Ya.
Photo session ya, Aziz?
What?
No photo session?
Photo session is the in the first, yes, the Nuya, yeah.
Okay.
Only first time. Okay.
Yeah,
okay, Professor Lina, you can leave the Zoom room and then we can meet again in the next weeks. Thank you very much. Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam. Izin live Pak John.
Iya, monggo. Saya juga. Ya, semuanya. Assalamualaikum.
Makasih, makasih.
Makasih, Bu Tati. Sukses.
Makasih.
Assalamualaikum.